Chapter 2, Part 8. Let's hope this is the last one. So, architectural, structural, this is what we covered so far. Structural systems and architecture. First is load bearing, second is post and lintel. And then we get into some different permutations of post and lintel. This is a lintel right here, and that's a post. Post is always vertical, lintel is horizontal. Your doorway in your house is a post and lintel construction, okay? But it's made out of wood. We're looking at stone examples here at first. When you get multiples put together, you get multiple lintels, multiple posts, then you have a colonnade, okay? Columns, these are individual columns, multiple columns in a row is a colonnade, and they're supporting the lintels, okay? Hypostyle is a grid of posts and lintels supporting the roof of a large interior space. So this is an Egyptian example here, Horus Temple in Egypt, and this actually even has, I think, some of the roof parts of it still intact, but these beautiful carved, very thick, large columns holding, there's your lintel right there, and then when you have this structure, you can support a roof on top of it. But that's a stone structure, so the width of these two areas is going to be narrow. Another example is Meniscales at the Temple of Athena Nike. And these are beautiful columns right here, and we're going to get into the styles of different columns. And here's our lintel across. Now, sometimes the lintel is a part of the architecture, and it's not standing out as clearly so you don't see it. But here we have column, and then we have lintel, lintel, column. Different styles of the Greek and Roman orders. Now, the Greeks are always first. Romans copy the Greeks and then alter things a little bit, if that makes sense. The Ionic column, the Doric column, let's start here. Doric column is the most basic, and it doesn't have a base that's decorative, not usually. There's exceptions to that. But at any rate, the Doric column is fluted and tall here, and it's very simple. Ionic would be later, and in terms of timeline, and then it has these sort of curlicues here at the capital. That's also a capital. That's a capital. This whole thing's called a shaft. There's not really a base per se with Doric. It's the only one that doesn't have a base. Then you move on to the Corinthian, and you think of the way I remember it is from Ricardo Montalban, which is way past your time. In the 70s, he advertised, I think 80s too, he advertised these cars, and he would say the Corinthian leather, which I don't really know if that was exactly correct. But anyway, it has sort of a fancy leafy design up here, which you can't see in this image very well. Now, when you get into the Roman order, that's your classic Greek order here, right? These three right here. Then when you get into Roman order, you have the Tuscan, the Roman Doric, which that one does have a base, and the composite of a couple different things, and that's got like those Ionic capital mixed with the Corinthian capital, okay? So the entablature is bigger than the lintel. It kind of is the lintel, but it's more than the lintel. See how this is the lintel right here? But this whole thing is called the entablature. And that's as far as we're going to go with that. When we get into wood frame construction, now we're doing our post and lintel, sort of, but it's a little bit different. We have a slightly different version of this when we get into Chinese, or we get into Asian art for the most part, and Asian and to some degree South African, or Sub-Saharan African, I should say, Oceanic, Australian. Those things all evolve quite differently, right? When we were talking about post and lintel previous to this, we're talking about Western civilization, which includes Egypt. I know it sounds a little strange to you perhaps, but that's how we include it. So here we are in China. Japan has a similar one to this as well. So we have our posts out of wood. Now we can have bigger open areas for two reasons. One, wood has more tensile strength. It's stronger across here. It's not going to crack at this point. It can go further apart, so you have bigger communal areas in the middle. The other reason is with this wood frame construction, with these brackets that you're seeing here, the load is being displaced. So it's kind of cantilevering it out so that it's displaced further out. So the weight that normally would be on the lintel is pushed out here, if that makes sense. All right, so when we get into our arches, this is how architecture developed, and this is mostly a Roman construction, and it also goes into Romanesque, which is 1,000 years apart. Don't get them confused. But the rounded arch was developed by the Romans, in the first century AD, so in year like 1, basically. In that time frame, they start to make the rounded arch. What you do is you put a bunch of wood or other material in here while you're constructing this. You get the keystone in there, and then you pull all that wood out. Okay. When you get into a barrel vault, that is just a row, but arch makes it into a vault, which is a long area. Okay. Let's see. A groin vault is going to be where two vaults connect. This vault and that vault connect, and it makes something that looks like a groin, kind of like a figure hitting two legs, that groin area, so it's called a groin vault. When you look at the construction of a church, when we go into some of these churches, you'll see this construction. You'll see these posts very, very high, and you'll see an arch. Now, the arch might be very light and small, but it has to be buttressed by a huge amount of weight. Arches displace a ton of weight onto the ground, so you have to be very careful about how you construct it. A dome is basically an arch that goes all the way around in a circle, and again, that weight has to be displaced off with buttressing, and these are called pendentives, these little triangular parts. I'm not going to get too much in the pointed arches because we'll get into that way later. So this is multiple arches and different roofs made of stone, and it gets in the dome here. Okay, so you can go through that on the regular PowerPoint. It's just going to be too much. Okay, so here we have a groin vault from the upside down. We have a pendentive right here off of a dome. So that explains to you this dome right here needs the weight to go shifted down into these columns, okay? But we're also calling that a buttress because that is buttressing up all this weight of the dome, okay? Excellent shot of a groin vault, a dome, pendentive. Okay, so another construction in the 20th century, and this starts actually, I think, in the late 1800s, but 20th century basically, the way that this gets developed, the steel and reinforced steel and concrete, steel frame construction changes everything, okay? So we've got the Industrial Revolution in the 1850s, which changes everything, and we'll get into that multiple times throughout the course. At any rate, this technology gets developed in the World War II era, and right out of World War II, no more focus on weapons and machinery and boats and planes and so on. And so we're developing all these new technologies during the war, and then just after that, there's a building boom, and they've got all these different ideas. And one of the things that they have is that they have plate glass, large pieces of glass that can be manufactured. Before that, windows had to be about 10 by 10 inches wide because they were blown glass. So we have plate glass, we have steel frame construction. The other thing that made buildings taller is the elevator. Okay, so this is the international style, and you do actually see this all over the world, but really it's basically in New York City and other large American cities, but you do see it elsewhere. So it makes it very tall, and it's very clean, no ornamentation, and it's got a lot of windows. All right, so steel frame construction, if you look at this compared to, go way back to load bearing, look how bulky that is. We have one doorway. That's it. That's all they can deal with all that stone. Lintel opens it up a little bit, arches and so on, open it up further. Then we get into steel, and now we can open big areas, right? We don't even need anything in here, a load-bearing wall in the interior, depending on the size and so on. But for the most part, all of the weight is off to the edges, and this is very light, so you can go up very tall, and those bottom floors are not getting squished, okay? Big open areas, very thin steel girders holding these up, I-beams, and they're welded together, and then big windows are put on there. Okay, so that we're going to get into reinforced concrete very quickly. Reinforced concrete has rebar, which you've probably seen in Home Depot, in the concrete. That's what reinforced concrete is. Beautiful example here is the Sydney Opera House in Australia. This thing went over budget. I think it was 3 times what they said it would be, $6 million, something crazy, to imitate the sails of the ships that were in the harbor here. And it went, see how many years it took to create, 20 plus years, or sorry, 12 years, 13 years. It was a long time, and it went way over budget. It's not used a lot, but it was a nice idea. In the 20th century, all these technology advances happen, everybody gets on board, but not all of them survive and really turn out to be cost effective. Okay, the truss and the geodesic construction. Trusses are forms that hold up a structure. Often there's one like right here holding up this corner to make it stronger, but trusses are sort of triangular segments that will hold up a structure. So this is held up by a variety of triangles, okay? So the geodesic dome was invented by Buckminster Fuller, and